differential equation, which is all about the solution of some first order, first degree. So this is Engineer Jana May Domingo, Instructor 1 from Summer State University. So we have several topics. So we are done with the variable separable and the homogeneous. And we have remaining topics such as exact, the linear equation, linear in a function, and the Bernoullis. So today we are going to discuss about the exact. So exact, it is defined that if the partial derivative of the function m with respect to y and the partial derivative of n with respect to x are equal, then the differential equation is said to be an exact. So we have function m as the function or any function with dx. So any function with dx should be called the function of m, which includes the variable x and y. While for the function n, it also includes the variables such as x and y, but it is always the function with the dy. So it cannot be interchanged. So any function with dx is function m, and any function with dy is function n. So in mathematical equation, we can express the definition of the exact such as this one. So the partial derivative of n with respect to y is equal to the partial derivative of n with respect to x. So in solving for the solution of the exact differential equation, we can use this equation. So we need to substitute our m and n in this equation and then probably solve for the solution, for the general solution. Now we can proceed in solving the steps in solving exact differential equation, and which is first to identify our function m and n in the given differential equation. So identify mo kung ano yung m at sino si n. And then we can now proceed in the partial derivative of n with respect to y and then the partial derivative of n with respect to x. And then comparing both if they are equal, and then we can say that the differential equation is said to be an exact. So next, the last is to substitute our m and our n in this equation. So substituting, we can apply or we can now perform the indicated mathematical operation to solve the differential equation. So for the first example, we have this equation, and then we need to identify which is m and which is n in the given differential equation. So we have already agreed that any function with dx is called our m, and any function with dy is called our n. So in this example, we have the e raised to y as our function m, while the function n is the quantity of x e raised to y plus 2y. And now, we are done identifying, so we can now proceed to the second step, which is to derive the function m with respect to y and to derive the function n with respect to x. So now, we identified our m and n, and first, getting the partial derivative of n with respect to y, that gives us e raised to y. Since e raised to y is just e raised to y. And then for the n, the function n, we have the partial derivative of n with respect to x. So in this case, we need to treat our y, any variable y, as constant. So this is treated as constant, and only x is derived. So deriving x, that gives us e raised to y na lang, and then deriving 2y, that is equal to 0 because the derivative of a constant is equal to 0. So the next part is to substitute now the m and n since we have proved that they are equal, and then we are now going to solve for the solution. So the first step for the solution is to substitute the m and n in the equation given in your screen. So this is the equation, and we are going to substitute our m and n in that equation. So perform the indicated mathematical operation and solve the differential equation. So we have this equation, And substituting our m and n, so that gives us our m is equal to ey, and then our n is equal to x e raised to y plus 2y, and our m is e raised to y. The first thing we do is to solve or integrate for the function of m with respect to x. So this is our first move or step in solving for the solution. We need to start with this, the integration of m with respect to x. So let us start with that. So integrating the function of m with respect to x, and just copying first na lang muna the other variables, because our concentration now is the integral of m with respect to x. That gives us x e raised to y. So we are going to derive for the x. So in this equation, for the m, we will treat the ey as constant. So we can just take out e raised to y because that is constant, and then integrating the partial derivative of x, that is equal to x. So we have x e raised to y, x e raised to y as our integral of m with respect to x. And then just copying the the function n. Let's now proceed to the next step. So the next step, after solving for the integral, we may now proceed in deriving the x e raised to y with respect to y. So in here, we are going to derive with respect to y. So now we treat naman the x as constant. So treating x as constant, as is lang siya. So we are just going to derive the e raised to y. So deriving the x e raised to y, that gives us still e raised to y. So next, we can combine x e raised to y and x e raised to y, but since the other x e raised to y is negative, then that should be cancelled. So 2y na lang. So we just have 2y. So the integral of 2y dy, that gives us this equation, that x e raised to y plus the integral of 2y dy is equal to c. So integrating this function, we just need to use the power rule, and that gives us this equation wherein we can cancel this because this is 2. So you just have 1 y raised to 1 plus 1, which is equal to 2, and that gives us the general solution, which is x e raised to y plus y squared is equal to c. So that was the end of the first example. That is very easy. So you just need to concentrate in using the integration and the formulas so that you can easily answer with the exact. So for example number 2, this is an example of the differential equation involving trigonometric functions. So starting, the first step is to identify which is m and which is n. So always, what is with dx is your m, and what is with dy is your n. So in this example, you have this cosine x cosine y minus cotangent x as your m, and sin x sin y as your function n. So let us proceed. Let us check if the equation is exact. So we have our m and n. So let us start with the m. So the partial derivative of m with respect to y, that gives us this equation, because partial derivative with respect to y, it means that our x, anything with variable x is treated constant. So cotangent x, that is constant. This is constant, the cotangent x. So deriving for cotangent x, that becomes 0. While for cosine x, cosine y, treating cosine x as your constant because it has the variable x, cosine x is constant. As is lang siya sa equation, you just need to derive cosine y. And deriving cosine y, that gives you the negative sine y. So that gives you the answer that the partial derivative of m with respect to y is negative cosine x sine y. Next, we have the partial derivative for n, but it is with respect naman with partial derivative of n with respect naman with x. So, in this case, you will treat naman y as constant, right? So, treating y as constant, we just need to copy the sine y, and then deriving for sine x, that gives you cosine x. Copying the sign, you have negative. That gives you the answer for the partial derivative of n with respect to x, that is equal to negative cosine x and sine y. Therefore, we have the partial derivative of n with respect to y and partial derivative of n with respect to x equal. So that means we have a differential equation. So next, we can now solve for the general solution. So solving for the general solution, we need to use this equation wherein our n is negative sine x sine y and our m is equal to cosine x cosine y minus cotangent x. So substituting the given, we have this next equation, and then our first move is to integrate the max. Integrating this part, that gives us this next equation, sine x cosine y minus ln sine x. So the integral of m with respect to x is equal to sine x cosine y minus ln sine x. So as you can see, this is with respect to x, the integral with respect to x. So we treat the cosine y or any function with variable y as constant. So if we treat any variable with y constant, we have cosine y as constant, so we just need to copy cosine y, and then the derivative of cosine x, that is sine x. Cosine x is equal to sine x, and then cotangent x, the derivative of cotangent x is equal to ln sine x, because if we are going to define cotangent x, that is cosine x over sine x, right? So this form, you can probably say that is ln sine x. So again, you need to familiarize the trigonometric function and then the properties of the functions, and also you need to know, you need to memorize, you need to recall or review the formulas for the derivatives and for the integration, so that if you can just directly solve or integrate or derive for that particular function, and then that is going to be easy. Kasi you don't have to read pa anymore. So, now, let's proceed. So, we just copy sine x cosine y because this is similar. So, you copy the integral of m with respect to x in this part. So, you have sine x cosine y ln sine x. So, now, we can proceed to the next part, which is to derive this function with respect to y. So, deriving that function with respect to y, we just need to copy this. So, copying that, we have this. And copying negative sine y, negative sine x sine y. And then deriving the function sine x cosine y minus ln sine x, that gives us treating variable x as constant, that gives us that the ln sine x is just equal to 0. And then you copy the sine x because that is constant, and then deriving for cosine y, that gives you negative sine y. But since you have negative sign here, the sign for that change, so you have positive sine x sine y. So we may now proceed to the last part. So observe, you have negative sine x sine y plus sine x sine y, that gives you 0. So you just cancel out this, and that gives you cosine x cosine y minus line. So that gives you, that gives you cosine x cosine y minus ln sine x is equal to c. But to simplify more the equation, we can say that our c can be ln c, and then applying the properties of the logarithm, we can have ln sine x plus ln c. And then from the properties of logarithm, that is also equal to ln c sine x. So the general solution is cosine x cosine y is equal to ln c sine x. So for more examples, we can use you can use the references I have used. So we have the differential equation 2nd edition work textbook and the elementary differential equation 7th edition. So I hope you understand something or you learned something from my video lecture, and I hope that you will also practice solving for other problems so that you can be more expert in this subject. So this is just applying integration and deriving. So if you do not know how to derive and integrate, this will be a lot harder for your part. So please study calculus because that is the basic foundation for this subject.